Trying to finish this paper. Yeah. Happy with the answer, this one? 22? Or you want me to
Yeah, it's
explain?
B.
You got B, okay.
Because one wavelength, right?
Yeah, one wavelength from compression to compression or rarefaction to rarefaction. Then you just use frequency speed over lambda. Okay, how about this one?
P.
Say again.
Boy.
Boy. Let's see what's happening. Transverse wave travels along a rope. The diagram shows the rope at time t equals 0. The wave is traveling from left to right. One particle of the rope is labeled x. Which graph shows the variation with time of the displacement of the particle x between t equals 0 and t equals 2 seconds? I'd like to know how it's moving. Let it be displayed slightly, no? Right? Where it displays slightly, you can draw on the paper, doesn't matter. They can see x is going down. X is going down. So where is x going down? X going down. X is 0, going down. So answer can only be B or D. X is moving downwards from 0 displacement. B, correct. Okay.
$500. Donkey.
Donkey. Right? If forgotten, remember when it's approaching the person, the wavelength is smaller, the frequency is larger. So that's the formula you can get from the data sheet. So it's approaching, you use negative. Right? Okay, yeah, right. Donkey. A telescope detects and analyzes some electromagnetic radiation of wavelength 2 cm. What type of telescope is it?
Radio. Wait. Oh, yeah. Okay, what?
Microwave.
Oh, okay.
Memory work only. This one you need to memorize wavelength of X-ray, typical wavelength, X-ray, typical wavelength of radio. Two waves of the same type overlap. When does the principle of superposition apply?
Always, right?
Okay, good.
Always.
Always, as long as there's two waves of the same type, as they overlap, we can use the principle of superposition. A stationary sound wave is formed in a tube of length L that is closed at one end. Diagram shows the position of the nodes and antinodes of the stationary wave, which graph shows the variation of the amplitude A of the wave with distance x measured from the closed end to the open end. Okay, what's your answer?
I think it's A. Teacher, but if it's open end on both, right, then it's B, right? If it's open end or both.
Okay,
But
A,
right now it's
if it's open end,
yeah.
then it would
B
be it's very hard to say though, because you have to change all this position of the node and antinode already.
Or let's say it's the same same position. Then it's B, right?
Cannot, because this will be an antinode lah. How to have two antinodes close together,
Oh yeah, that's
right?
true. Hmm.
What happens when the frequency of the wave is half?
More diffraction.
Yeah, what's the answer?
Boy.
Okay, why correct? Wavelength is double, so more diffraction lor.
Boy. So it's boy.
The intensity of light emerging from one of the slits is now reduced. How does affect the interference pattern? The bright fringes and the dark fringes becomes darker. You say, boy, let's see. Donkey, when the intensity is different, the amplitude
Oh.
is also different. So no complete cancellation occur. Cancellation, they must have the same amplitude. Intensity of bright band is reduced. Right? Constructive interference, intensity is different, so intensity is reduced. So amplitude is different, so intensity is reduced. So can or need me to explain further?
Mm.
Not constructive, not destructive interference completely, because amplitude is different. You will still see some intensity lah, because the amplitude doesn't cancel off for destructive interference.
Okay.
Okay, happy.
Hmm.
The bright fringes become darker and the dark fringes becomes brighter. Intensity lower lah. Dark fringes becomes brighter because no more cancellation already. Okay, how about this one?
Let's see.
Memorize the formula, put in the formula, all the calculate theta. See, okay, good. How about this one?
A so I'll put A.
Right? There's a formula I equals Q over T. I is constant, right? I is constant, is the current flowing through the wire is a constant, doesn't change. So it means that Q over T is constant. So QT, where we start from this area, and the QT will Q1, T1 at this area will be the same. So Q1 is what we are interested in. How much charge will pass through the end in the time interval of T over 4. So cross multiply 1 Q1 T1 across there, Q over T, then divided by T over 4 becomes quarter. Answer is B. Okay. Any comment or anything you not clear?
Nope.
Okay. What's the answer?
C.
Boy,
No, cat.
cat, okay. Oh, 12 volt across a wire or resistance. That power supply is 3.6 volt. We can find the current, right? 0.3 ampere. Power dissipated in the wire is I square R. Okay? I is that? I square. R is given there. The energy is PT, 0.4 watt times 3600, 1 hour. Change to second. Cat, okay, good. How about this one? Now I have to do with resistivity lah.
A.
Resistive formula, work with that. Yeah, told copper wire is replaced by aluminum alloy wire of the same length. Resistance, same length and resistance constant. So get the formula we use. Right? L and R constant, so it is R over A, rho over A. So this is the original copper. This one is alloy. Then you want the ratio of the diameter of alloy, diameter of copper. Then you square root it, square root that. Okay, A. Any comment or anything not clear?
No.
How about this one?
Okay, then Q breaks.
Q break, so that it no longer conducts.
P will be brighter and R will be dimmer.
B will be brighter, R will be dimmer, so answer is B lah. The current through P will be larger. Right? Previously, the current is shared between both of them. The current in P will be larger, thus it will be brighter. Correct. Total resistance in the circuit increases. Right? Previously, this is smaller. Now, there's only one resistor. So smaller current passing through R is less, right? You are right. You are good. You are improving. What's the answer?
Energy transfer per unit charge.
Yep.
C.
Okay, good. How about this one?
So I simply put on so I put like C also.
You don't just guess, so you put C. Let's see. Right? Let the total resistance be X for these two together. So ratio of X over 10, right? X over 10 must be equals to 2 over 5. Right? Potential across here divided by here is the same as across here divided by across here. Or resistance is It's actually called Wisdom Bridge, but the syllabus doesn't mention it. X is 4, then take the reciprocal. This is parallel. 1 over R, 1 over R plus 1 over 8. You want 1 over R, so you take 1 over 8 across, it comes minus 1. Donkey. Can?
Oh, okay.
Anything not clear?
Yeah, but I don't understand how this works.
Basically, the potential across this one, the ratio of resistance 2 divided by 5 is equals to the resistance of X over R. If this is the voltage, give 0. It's called balance.
Oh, X over R.
2
Oh,
over
yeah, okay,
5
okay.
is X over 10. Okay?
Yeah, understand.
It doesn't mention a syllabus, but it just come out. This is called Wisdom Bridge.
I thought it's called the potential without divider.
And you can think of it as potential divider also can. It's also potential divider idea. If you think of potential divider, then you can easily understand. The ratio is the same. Since both are the same potential, then the ratio of that R over R 2 over 5 is X over 10. Okay,
Okay. Yeah. And see.
See, is it?
Yeah.
Reduce the intensity of light incident on the light dependent resistor. Reduce the intensity. Potential here becomes greater. Potential at X must be larger than Y. Right? If you want to, which change on its own will cause the voltmeter to show a positive reading. The positive reading will mean that X has a higher potential than Y. Reduce intensity of LED, increase the PD across, reduce intensity of LED, the resistance will increase. So the PD across LED decrease. What am I doing? Reduce intensity of LED increases the PD across. Sorry. Uh, okay, basically they are sharing potential difference. If that potential is reduced because the resistance becomes smaller, then the potential of this one will increase. C, you're right. Any comment?
No.
How about this one?
C.
B,
Oh,
alpha
okay, okay.
particle pass close to a gold nucleus and is deflected through an angle greater than 90 degrees. Which property of alpha particle changes as a result of deflection? Momentum,
Yeah, it's true.
right? It's a collision experiment. How about this one?
So I got A.
In alpha decay, A decreased by 4. So you work with the A first. Subtract there. These two divided by 4, 8. Then calculate the decrease in Z. Z decreased by 2. So 8 alpha 2 times 8 is 16. That will decrease by 16. Right? That will decrease by 16. But for beta minus decay, A is constant, Z increase by 1. Right? So you got 82 here. You got 76 here. So subtract. A, yeah, right? Any comment?
No.
Which list of particle contains only fragmental particle?
Oh shit. So I
Yep.
simply put on
Say again. This one is more memory work.
uh
What's your answer?
I put D
Bayon is a neutron, a proton, donkey.
Oh, okay.
Okay, your line should go that way. Can
Wait, let me open.
anything you don't agree? This one testing you about quantity and unit lah, base quantity and base unit. Yep. Anything don't
Hmm.
okay a set of experiment is described as precise and not accurate. What is meant by precise?
The data close to each other.
Rather than data, the measurements have a small range or close to each other. Not
Yeah.
accurate.
Far from the answer, like true value, true value.
Uh, average measurement not close to the true value. Right? This is memory work. Calculate the percentage uncertainty in V.
Six
Can
6%.
right? Use this formula. Subject V, take the square root. So square root means half of percentage F, percentage R, percentage M. In your value for F. F is 3. R is 5. For 6%, correct. Value of V is 15.0 cm. Calculate the absolute uncertainty in V. What do you get?
4.9.
Okay, 0.9, correct.
6% times
Anything else
15.
you want to ask on this question?
No.
No, happy with that.
Uh,
Okay, let's go to number
Sure.
2 then. Yep,
If it's let's say it's a square, right? Square then is 2 times 2, right?
square A times 2.
For
If it's a square, then times 2 here. This one square root means half.
cube root.
Cube then times 3. If it's a
Oh,
cube
okay,
of the
okay.
whole thing, then times 3 here. Any other question?
Okay. No.
Okay, let's do number 2 then. A steel ball is projected horizontally from the top of the table as shown in figure 2.1. Clear already, you got picture horizontally, there's a distance, there's a table. Calculate the time taken for the ball to reach the ground. What's your answer?
0.4 seconds.
Use these two, lor. Treat as if this one, this ball is traveling that way, lor.
I use horizontal component.
Horizontal distance divided by horizontal velocity, lor. 0.37 second, lor. Okay with that?
Wait, x.
X is that distance. Change it to meter. And then the speed, 4.9.
Oh,
Yep.
you can do that. Because I use the long formula. UT plus half AT square.
Basically, the horizontal, no acceleration, no force. So it's uniform
Yeah, that's
velocity.
true.
Calculate the
Oh, so
vertical
if there's no
component of
acceleration involved, I can use that lah.
horizontal, no acceleration, just uniform
Means I can use
velocity.
that lah.
I can use that.
Okay.
Vertical one got acceleration. Calculate the vertical component of velocity as it hits the ground. Right? To calculate the time.
3.6.
Right? Have a picture of what is happening. Taking downwards as positive. Initial is 0. Vertically, initially is 0. That's the time that we calculate. 5.81. G. Then put in your value. 3.6. Okay, correct. Determine the magnitude of the angle to the horizontal of the velocity of the ball as it hits the ground. So the angle, right? There's a vertical component and horizontal component. There's a resultant velocity as it hits the ground. Okay, use Pythagoras theorem and take tangent of
Oh,
3.6 divided by 4.9. This one you have problem, you must be very weak really. This is you did in further math somehow.
yeah.
And any comment?
No.
Okay, happy with that.
Hmm.
You try to cover as much syllabus as possible. The ball is projected by means of a compressed spring, which is attached to the fixed block as shown in figure. The ball is placed on a frictionless track in front of the spring. Ball is then pulled back so that the spring has a compression of x naught. The spring is released, the ball is projected horizontally as shown in 3.3. So that's the graph. Direction of compression x of f of the spring is shown. Calculate the density of steel. What is your answer? Right? Volume is quarter pi r cube.
7.926.
Diameter. So you divide by 2 to get the radius of volume. Then density is mass over volume. Can any comment?
Yeah. Oh, sorry.
All the elastic potential energy in the spring is converted to kinetic energy of the ball. The speed of the ball as it leaves the spring is 4.9. Show that the maximum elastic potential energy of the spring is okay. Okay, we've got 10 more minutes. Right? Elastic potential equal kinetic energy, half mv square. Half is 0.5 mass. That's your mass. speed is 4.9. Okay, that's all. Any comment? Anything not
No.
clear? Okay, no?
Yeah.
Okay,
Yeah.
Use figure 2.4 to determine the spring constant of the spring. What is your answer?
FOX. So I got 64.
F over x, take any value, lor. Right? Easiest is to read here, lor. 10, and then 6.4, lor. 64, lor. Right? It's just a ratio, any point you can use. But use a point that's easy to read. Use your answer in B part 3 and the value of energy given to determine the compression X naught of the spring. What's your answer?
0.08.
Basically getting you to memorize the formula, lor. Half kx squared. So that's your x naught. Cross multiply, take k down, and square root it to get x naught. In your value, 2 times 0.2, k is 64. Okay. A steel ball is replaced by a polystyrene ball of the same diameter but a much lower mass. The spring is given a compression of x naught and then release. Air resistance on this ball is not negligible. After it leaves the spring, explain why the ball leaves the spring with a greater speed than that of the steel ball. Yep.
Why the ball leaves the spring with greater speed?
Basically, you just use the
Uh,
formula that you have been using to calculate previously and argue it out from there. Can?
Same elastic potential energy. So same kinetic
Basically,
energy.
there's a formula, and then there's a kinetic energy formula, right? E is constant. E is still the same. You have compression, but your mass is now smaller,
Lower mass.
right? Same
Lower mass means
diameter,
more speed.
but much lower mass. The key is the hint is lower mass. Okay. So same elastic potential energy or same initial kinetic energy. Polystyrene ball has a smaller mass, so greater speed. Can?
All right.
Why is the ball takes a longer time to reach the ground than the steel ball?
Air resistance, drag force. Drag force. Wait. Longer time to reach the ground is
Polystyrene ball, there is less average vertical acceleration. Right, you have to explain now. Right? Cannot say drag force alone, it won't give you any mark.
Oh,
Right?
okay.
There's less average vertical acceleration because of the air resistance or smaller average vertical component of the resultant force. So it takes longer time to reach the ground.
Sure, cannot say higher drag force, man.
Higher drag force doesn't explain anything.
Hence, like, reach slower.
Higher drag force, so the acceleration becomes smaller, so it takes longer time.
Yeah.
Okay, you have to explain.
Okay.
I cannot say higher drag force. How does the drag force come in?
From the air resistance.
Okay,
Yeah.
define power, memory work, nothing much. Work done per unit mass. Sorry, time per unit time.
Uh,
Use the concept of work and definition of power to show how the formula is derived. Right, put down is Fs. Power, definition of power is W over T. Put down over time. I'll put inside there. Okay, can?
Yeah.
Engine or lorry provides 130 kilowatt of power to the lorry's wheel when it is traveling at a speed of 25 meter per second along a straight horizontal road. Show that the resistive force
5,200.
constant. Can get?
Yeah, okay, can.
Right?
I use the
Yeah.
formula that we got just now. P equal F V.
Constant speed means resistive force equal applied force. So it's power divided by, it asks you to derive the formula. So they want to use the formula. No? Change it to what? And then the speed is 25, so it's 52. The lorry in B travels a straight section of the road that is inclined at an angle of theta to the horizontal. The lorry has a mass m and acceleration of free fall g. Determine an expression in terms of m, g, rho, component of weight of the lorry that acts to the surface of the road. Yep.
mg cos theta.
Can
Wait, no, mg sin theta. Right? Should be mg sin theta.
component of weight is mg sin theta, no? Correct?
Yeah.
Right? There is theta. This is also theta, so it's mg sin theta. No? Determine the power now provided by the engine.
Yeah.
Can
Driving force. Yeah, I use the driving. Find the
passed by the
driving force
engine.
first.
F equals to component of weight plus resistive force. Right? Component of weight is going down.
About 30.
Resistive force is going up, so resistive force is going down the plane. So add the two. No? Right? Add them up.
Yeah.
Okay, can?
Mm.
Any comment or anything not clear?
Okay.
Say the meaning of polarization. Okay, memory work. Oscillations are in single direction, which is perpendicular to the direction of propagation of the wave. Oscillations are in single plane, which contain direction of propagation of the wave. Right, anytime we cut off. So I see you next Tuesday.
All right.
Anytime you cut off, continue to do the partial paper that I've asked you to do. State why the light wave can be plane polarized but not sound wave. Yep.
Light waves are transverse and sound waves are longitudinal.
Okay. No? Light wave is transverse. Sound wave are longitudinal. Okay, calculate the angle of rotation of filter B. Starting position. Memorize this formula.